Subtracting and comparing fractions. Like denominators. Two or more fractions are said to have like denominators when they both contain the same denominator. For example, 5 over 12 and 1 over 12 have like denominators. They have the same denominator, so they're called like denominators. They're both the same. So we're going to talk about subtracting fractions with like denominators. It's exactly the same, it's almost the same procedure as adding fractions with like denominators, except that we're going to subtract. So subtract the numerators, and then we're going to write the result over the original denominator. So the denominator does not change as long as the denominators are the same. And then step 2 is reduce if possible. Okay, so example 1, subtract 5 over 12 minus 1 over 12. So 5 over 12 minus 1 over 12. 5 minus 1, that will be 4, and then the denominator stays the same. And then we could reduce it, so if you left the answer as 4 over 12, you will not get full credit on a test. You'll probably get partial credit. So 4 over 12, and then you could divide both the numerator and denominator by 4. That's the greatest common factor. The largest number that divides into both numbers. So what's the largest number that divides into both? Right, we just said 4. So divide them both by 4, and that gives us 1 over 3. Okay, let's do another example. Again, like maybe I went too fast there. Always pause it, go through it again if you want to, write down the steps. Alright, let's do another one. 7 over 18 minus 5 over 18. Just like the last one. Again, you might want to pause the video and then click on play when you're ready. Both these examples, the denominators are the same. And then we'll start talking about how we work it out if the denominators are different. Okay, so 7 over 18 minus 5 over 18. Subtract the numerators. So 7 minus 5, that will be 2. And then divide both numerator and denominator by 2. So that gives us 1. So 1 over, and 18 divided by 2 is 9. 1 over 9. Make sure you keep the answer as 1 over 9. If the answer were 9 over 1, that would be 9. But 1 over 9 stays 1 over 9. Okay. Next one. Again, you might hopefully pause it and work out the second one. This one has 3 fractions, and the denominators are all the same. Okay, so we'll write it as one fraction, 11 minus 7 plus 3. And then with the order of operations, which one goes first, addition or subtraction? That's right, we have to remember that when working with addition subtraction, we work from left to right. So if you said addition, that is incorrect. I know we all have that saying, please excuse my dear Aunt Sally. I really hate saying that because it leads people to believe that it's addition and then subtraction, right? That's just not true. It's wrong. It is not addition and then subtraction. It's addition or subtraction. If they're next to each other, it's left to right. Same applies to multiplication division. If they're next to each other, it's left to right. So you might want to consider, if you have a chance, go through the video on order of operations that I have on this website. So it's not addition then subtraction, it's addition or subtraction. They both have the same priority, so to speak. So since the subtraction is written first, we're going to do the subtraction first. So it's 4 plus 3, which would be 7 over 20. Okay. Yeah, I know. You could see that if you did it the other way around, if you did the addition first, and you would have got 7 plus 3 is 10, and 11 minus 10 is 1. You would have got 1 over 20, right? Yeah, you can see you'll get a different answer if you break the rules, but you can't break the rules. Not in math. Okay, let's go to the next problem. Actually, the next type of problems, unlike denominators. When two or more fractions are said to have unlike denominators when they both contain different denominators. So when the denominators are different, they're unlike. And this is our procedure for subtracting fractions with unlike denominators. Number 1, find the lowest common multiple for the denominators, and we're going to call it the LCD. Number 2, write each fraction as an equivalent fraction using the LCD for the denominator. Now, some students prefer to write the fractions vertically, so we'll do that a lot in this lesson. It's just a preference. It doesn't really matter. Okay, number 3, subtract the numerators. So now that we have the same denominator, now we're back to the previous types of problems where we could go ahead and subtract the numerators, and then we're going to write the result over the LCD. And number 4, reduce if possible. Okay, so you might want to pause, write down the steps, and then we'll get started on some examples. Okay, we'll move on. Here's our first example. 11 over 20 minus 2 over 15. So, step 1. First we're going to find the LCD. So you're going to find the prime factorization of 20 and 15. I'm going to show that. I'm not going to show the tree. You might want to do the tree for both 20 and 15. Or maybe you do the division box method, whichever one you prefer. So 20 is 4 times 5. And the 4 is 2 times 2. So 20 is 2 times 2 times 5. And 15 is 3 times 5. So there's a result. There's a prime factorization of 20, and 15 is only 3 times 5. Okay, so I just wrote the results down. Take a second, do the tree for each number. Now, we're going to write down the LCD, just like we did LCM before. We're going to consider each prime number and write each prime number the greatest number of times that it occurs in any one row, and any one row only. So we're going to start with the number 2. What's the greatest number of times it occurs in one row? And that's 2. 2 times, right? So the number 2 occurs twice. And then the number 3. What's the greatest number of times the 3 occurs? Once. And then what's the greatest number of times the 5 occurs in one row? What's the greatest number of times the 5 occurs in one row? Once. We're not asking how many times does it occur altogether. We're saying what's the greatest number of times it occurs in one row, and that's only once. So we're going to have 2 2's, 1 3, and 1 5. And that multiplies to be 60. Okay, so that's going to be our LCD. So we're going to write this vertically, and then that's going to be our new LCD that we're going to write over to the right. We're writing this as equivalent fractions. After we're all done, we'll write it horizontally, and then if you want to leave it horizontally, that's your preference. Okay, so 20 times what number is 60? Now, you could either divide 20 into 60, or if you could see 20 times what number is 60, if you do that in your head, or you could use these numbers over here. Let me change this to a pen. 20 is a 2, a 2, and a 5. So if you cover up a 2, 2, and a 5, what's left? 3. See that? 20 is 2, 2, and a 5. So if you underline, I'm going to underline the 2, 2, and a 5. Oh, that's not a 5. Oops. So 2, 2, and a 5. So what's left? 3. So that's why it's 20 times 3. And that's right, because 20 times 3 is 60. Okay, it's just a quicker way than dividing. Especially when these numbers get large, I want you to be able to find that number quickly without dividing. Let me erase those and let's try it one more time. Let me erase these little marks here. Let's try it again. Sorry if this is kind of messy. Change it back to a pen. 15. 15 is a 3 and a 5, right? So there's a 3 and a 5. What's left? 2 times 2, which is 4. So that's the 4. Okay. So that gives us 33 in the top numerator and 8 in the bottom numerator. And now we could subtract, because they're like fractions, 25 over 60, and then that reduces to 5/12. Okay, let's try another problem. Okay, you might want to pause, make sure you work that all out if you haven't already finished it up. Oh, I did say we were going to write it horizontally. Sorry about that. Okay, so we're going to put 60 below each of those. And then same idea, 20 times 3, so put 3 next to it. And then so we have, that'll be a 33. And then 15 times 4 is 60, so put the 4 next to the 2 also. So 33 and the 8. And then we can subtract that, 25. So it's still the same thing. It's just a matter of preference. I kind of like writing it vertically. That's just my preference because that's how I learned it. Quite often the way you learned it is always going to be the way it's easiest. A lot of times if you were born in another country, you probably learned to write everything horizontally if you've done fractions before. And you may remember doing that horizontally, so that might seem easier to you. Okay, let's go on to another one. 22 and 30. Okay, again, you might want to pause, find the LCD. So for 22 and 30. Find the tree, or do the tree for 22 and 30. Find the prime factorization of each number. 22 is 2 times 11. 30 is 2 times 15, and 15 is 3 times 5. Okay, so the greatest number of 2's that occurs in one row is 1. The greatest number of 3's that occur in one row is 1. 5's that occur in one row is 1, and 11's that occur in one row is 1. So quite often what will happen is people will put too many 2's there. Well, what will end up happening is your LCD will not be an LCD. It'll be a common multiple, but it won't be the lowest common multiple. And you'll have more reducing at the end. So it's not like it's a major issue, but it could create some problems later on down the line in algebra. Okay, anyways, multiply that out and you should get the LCD. We will get the LCD. And I got 330. I'm going to write it vertically and put that as our new denominator. Now let's try to figure out 22 times what number is 330. Okay. Now, in the old days, or what your teacher might have told you in the past, was to divide 22 into 330. And you still can do that. So if you want to, you could do it that way. And that'll give you your answer of what number goes here. Okay? I don't want to do that. But this is what you can do. So 22, so find the 22 over here, 2 and 11, 2 and 11, so go over here, cross out the 2 and 11, 2, and what's left? 3 and 5. Multiply that out, and that's your answer, 15. 15. So if you divide 22 into 330, you'll get 15. Okay, erase my marks now. Probably a faster way of doing that, but I don't know. Okay, so 30. 30 is, I'll try to do it without making marks. 2, a 3, and a 5, right? 30, so I'll find the 30 over here. It's 2, 3, and 5. So kind of mentally cover up the 2, 3, and 5, and what's left? Just the 11. So that's what's going to go right here. Times it by 11. Okay. Now we can multiply 9 times 15. Let's see, 9 times 15. That gives us 135. And 7 times 11 is 77. Now we can subtract. And that will give us 58. Maybe I'm going too fast. Take your time, pause the video at any time, work out each little problem for yourself. So 58 over 330. All done? No, right? We still got to reduce. Because 2 goes into both numbers. So we could divide them both by 2. 29 over 165. And I boxed it because that's done. 29 is actually a prime number. And that doesn't go into 165. Okay, let's move on. 3 fractions. So we are going to find the LCD for 15, 10, and 12. Well, we're going to go ahead and do the tree for each number, the 15, the 10, and the 12. So write down the tree for 15, the 10, and the 12. 15 is 3 times 5. Again, you might want to pause, work out each of these for yourself. 10 is 2 times 5. 12 is 2 times 2 times 3. Okay, so what is our LCD then? How many 2's? That's right, 2, because that's the most number of 2's that occur, so 2 2's. How many 3's? Just 1. And 5's? Just 1. Good. So our LCD is 60. That's the smallest number, lowest, smallest. That's the smallest number that 15, 10, and 12 divide evenly into. That's the lowest common denominator. This one, since it has 3 fractions and we have subtraction and addition, let's leave it horizontally. Okay, 15 Now let's go ahead and put that 60 on the bottom below each fraction. So now we'll figure out 15 times what number is 60? Well, 15 is 3 and 5, so cover up a 3 and a 5. Kind of do it mentally. What's left? 2 2's, which is 4. So that'll be, and that's right, 15 times 4 will be 60. So we'll move on to the next one. 10 times what is 60? Well, we know that in our head, 10 times 6, but 10 is 2 and 5. So if you cover up a 2 and a 5, you got this 2 and 3 left, which is 6. Okay, and then 12 times 5, 12 is 2, 2 and a 3. So 2, 2 and a 3, we have a 5 left. So 28, 18, 25. Now we can go ahead and work it out. Because all the denominators are the same, we'll go ahead and work out the numerators. 28 minus 18 plus 25. Which one do we do first? The subtraction or the addition? Yeah, you got it. Left to right, right? You didn't say addition, did you? No. So 10 plus 25 is 35. So 35 over 60. And can we reduce that? Yeah, we can divide them both by 5. 5 goes into 35 7 times, and 5 goes into 60 12 times. So 7 over 12. Okay, we're doing all right? Yeah, I think so. Okay, let's move on. Inequality symbols. We use these inequality symbols, the less than and greater than, to show which number is greater. Or less, we could say that. So the first one, we have A is greater than B, and that's what it translates to. And the one to the right is saying A is less than B. So here's some examples. The top row is saying 12 is greater than 5, and the bottom row is saying 8 is less than 13. So the inequality symbol always opens up to the larger number. You could also say it points to the smaller number. So I kind of like to say it opens up to the larger number. Okay. Okay, but we're going to talk about fractions. So here we go. If the denominators are the same, compare the numerators. The fraction with a larger numerator is a larger fraction. Okay, so as long as the denominators are the same, as long as the bottom number is the same, all we need to do is look at the top number. Whichever top number is larger, that's the larger fraction. Not too bad, right? So which of these numbers, so we're looking at part A first, which is larger, 4 or 7? That's right, 7. So 7/11ths is larger than 4/11ths. You could say that 7 out of 11 people is greater than 4 out of 11 people. Okay. So it opens up to the 7/11ths. Okay, B, which one's larger? 11/17ths or 2/17ths? That's right, 11/17ths. Okay, so this is an example when the denominators are not, this is an example when the denominators are the same. Well, what about when the denominators are not the same, right? If the denominators are different, change each fraction to an equivalent fraction using the LCM for the denominators. Then, compare the numerators. The fraction with a larger numerator is a larger fraction. So we have to make the denominators the same. We have to change them to equivalent fractions. Okay, here we go. So write an equality symbol between the following numbers. So we want to know which one's larger, 5/12ths or 7/15. So first of all, we need to find our LCM for the denominators, our LCD. So we'll work with 12 and 15. Let's do the tree for 12 and 15. 12 is 2 times 6. 6 is 2 times 3. 15 is 3 times 5. Okay, so our LCD, let's see. How many 2's? That's right, 2. How many 3's? 1. And how many 5's? 1. So that gives us 60. So now we're going to write each as an equivalent fraction with a denominator of 60. Okay, so 12 times what number is 60? And try to be organized, like write the 5/12ths on the left and the 7/15ths on the right. So that will be times 5, and the 15 times 4 will be 60. So 5 times 5 is 25, and 7 times 4 is 28. So we've done it. We've changed them to equivalent fractions. Now we could tell which one's larger. Is 28 60ths larger, or is 25 60ths larger? Yeah, the 28 60ths. So that means the fraction on the right is larger. So 7/15ths is larger than 5/12ths. So when we write our final answer, it'll be opening to the 7/15ths. Okay, make sure you write your answer with the original fractions. Don't use the 25/60 and the 28/60. Write an answer with the original fractions. Okay, so it's just like like we were doing with adding and subtracting fractions, but we're just not adding and subtracting. We're just putting the symbol in between to say which one's larger or smaller. Okay, let's move on. Ordering fractions. If the denominators of 2 or more fractions are identical, then we could arrange the fractions by simply comparing the numerators. Arrange from smallest to largest. So we're going to just put them in order, going by the numerators, as long as the denominators are the same. The one with the smallest numerator goes first, and the one with the largest numerator goes last. Let's see, which one goes first? The 2/11ths. Which one's the next smallest? 4/11ths, and then the largest would be 7/11ths. That's it. Just arranging them from smallest to largest, going by the numerators. Now that's if the denominators are the same. Well, what if the denominators are not the same? Well, that's right. Then we have to make them the same, right? We have to make them the same by finding the LCM. So write each, if they're not the same, write each as an equivalent fraction using the LCD. Okay, so again, you might want to pause this one for a little bit of work. Find your LCD for 9, 12, and 27. Okay, so 9 is 3 times 3. 12, 2 times 2 times 3. 27, 3 times 3 times 3. So how many 2's? Just 2. How many 3's? 3, because the 27 has 3 3's. That's the greatest number of 3's that occurs in any one row. So 2 2's and 3 3's, and that gives us 108. So now we're going to write all 3 fractions, and we're going to change them all into denominators of 108. And now we have to figure out 9 times what number is 108, 12 times what number is 108, and 27 times what number is 108. Let's see, 9, let's start with the first one. 9 is 3 times 3, so if you cover up 3 times 3, you got 2 2s and a 3, which is 12. So the first one's going to be 12. That means 9 times 12 is 108, so that means 12 times 9 is 108. 27 is 3 3s, so here's 3 3s, so it must be 2 2s, which is 4. So 9 times 12, 12 times 9, 27 times 4. And then multiply the numerators. 60, 63, and 52. So now we could arrange it. Which one's the smallest? The 52 is, right? So, but we're not going to write that number. We're going to write the original fraction. So the smallest is 13 over 27. The next smallest is the 60, which is 5/9. So 5/9 will be the second fraction, and then the largest will be the 7/12. Okay, a little bit of a long lesson, but we got through it, and hope it's going okay. We just have a couple more in this set of fractions. We have adding and subtracting mixed numbers coming up. So I'll see you here for the next video. Have a good one.